Okay, this lesson is on using derivative rules, and we're going to be using the power rule, chain rule, and exponential rule possibly and manipulating them using our rules from graphs and tables. Okay, a couple things before we start. If you have 1 over a function that I'm just calling f right now, remember that if you're taking the derivative of it, you have to think of that as that function to the -1 power. And we discussed that in our previous lesson. If you had a number on top, and I'm just going to use pi because we need to remember to think of pi as a number. If you had a number on top of that function, you would still need to rewrite that as that number times that function to the -1 before you started taking the derivative. The only time when you don't do that is if you have one function on top of another and they both have x's in them, and in that case, that is when you use the quotient rule. Okay, so x is on top and bottom, use the quotient rule. X is just on the bottom, turn it into a power. Okay, for our first example, we are going to work with given information. And this given information gives us the f value where x is 1, the derivative where x is 1, the g where x is 1, and the derivative of g where x is 1. All those outputs. And basically, we're going to be doing the same kind of thing with each problem. It's just how they give us the information. In this case, they're just telling us what that information is. And so each one of these is really testing your knowledge of the rules. So part A, if I have f plus g, when you have two things added, you just take their derivatives separately and not worry about it too much. It's just kind of common sense almost. So f plus g prime of 1 means I'm going to do f prime of 1 plus g prime of 1. I'm just going to take those derivatives separately at 1. And I look up here to find that information. F prime of 1 is 5, g prime of 1 is 2, and 5 plus 2 is 7. And so that's my answer. In part B, I have a number in front of g, and that number does not have an x with it, so whenever you have that situation, you just bring that number down, and then I have the derivative of g at 1. You just bring it down and take the derivative. So that becomes 4 times 2, because g prime of 1 is 2, and that is 8. So those are both basic. Now, what this type of problem is most commonly used for are checking to see if you do the product and quotient rule. C is a product of f and g, and therefore you must do the product rule. Don't just say f prime of 1 times g prime of 1. So when we're taking derivatives and things are multiplied, we got to do the product rule. So the product rule in this case would be first times the derivative of the second plus the second times the derivative of the first. And then I fill in what those numbers are. So f of 1 is 3, g prime of 1 is 2, g of 1 is -1, and f prime of 1 is 5. So here I have 3 times 2, which is 6, plus -1 times 5, so that's -5. So my answer is a +1, and I've used my product rule. Okay, for D, we have f over g, which is a quotient, so I'm going to be needing to use my quotient rule. So I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So when I start to plug in, g of 1 is -1, f prime of 1 is 5, f of 1 is 3, g prime of 1 is 2, and then again g of 1 is -1. So on top I have a -5 minus 6. On the bottom I get a +1. So my answer in this case would be negative 11. For E, we have 1 over f plus g, and because it's a 1 on top and not a function, I need to think of that as f plus g to the negative 1. So I'm going to be doing a chain rule. Now this might be slightly confusing, and you might even want to go ahead and think of that as f of 1 and g of 1, because that's really what we're going to be doing when we write this out. So, okay, that's just algebra or thinking. Now I'm going to do the derivative. So this is a chain rule. I need to do the outside, so negative 1, keep the inside the same, we have the negative 2 power. The inside would be f of 1 plus g of 1. Then we multiply by the derivative of the inside, and that would just be f prime of 1 plus g prime of 1. Okay, so then we plug in our numbers for each of these values, and I have to think about what this means. So 3 plus negative 1 is 2. It's negative 2 to the negative 2 power. So that is 1 over 2 squared, because that negative power says move it to the bottom and square it. Then I'm multiplying that by 5 plus 2, which is 7. So I get a negative 7 over 4 as my answer. Okay, f looks similar, but because it has the f on top, that means it's a function. We've got to use a quotient rule. And so I'm going to say the bottom, but I'm going to plug in the 1. So f of 1 plus g of 1 times the derivative of the top, so f prime of 1, minus the top times the derivative of the bottom, which would be just f prime of 1 plus g prime of 1, all over the bottom. So f of 1 plus g of 1 squared. Okay, so we plug in our given values and then we just work it out. So 3 plus negative 1 is 2, and 2 times 5 is 10. 5 plus 2 is 7, and 7 times 3 is 21. And then again, 3 plus negative 1 is 2, 2 squared is 4. So I'm going to get a negative 11 over 4. Okay, so for example 2, we're going to be given the information in a chart. And it's going to basically work the same way as what we were doing before. We just have to look up the information in a different way. Okay, so our table gives us our information, and if we look at A, we just have G minus F, and anytime we just have two things that are subtracted, we can just do their derivatives separately and subtract them. So G prime of 2 minus F prime of 2. And so G prime of 2, I'm looking up G prime and the x value of 2, that gives us a negative 3. So negative 3 minus, and then f prime of 2. F prime and 2 come together at 7. So negative 3 minus 7 will be a negative 10. So again, there are basic problems like that. Now, part B, we have a composition, which we are doing the derivative of, which means I've got to do a chain rule, because chain rule exists because of composition functions. So I do the derivative of the outside and keep the inside the same, and then multiply by the derivative of the inside. Except we're doing these at 3. So I'm doing f prime of g of 3 times g prime of 3. So it's just your chain rule, but using function notation. So the first thing I'm going to do is find g of 3. And g of 3 is 2. And then I'm multiplying by g prime of 3. G prime of 3 is negative 4. But I'm still not done because I still have to do this outside part, the f prime of 2. So f prime of 2 is 7. So I'm doing 7 times negative 4 and getting negative 28. Okay, for part C, I'm taking the derivative of 4 over f of x, and again, there's no variable on top, so I need to look at that as 4 times f of x to the negative 1. The f of x is to a negative 1 power. So when I'm doing the derivative, I bring down the 4. I'm doing the outside, so negative 1 times 4 will be negative 4 f of x to the negative 2, so chain rule, and then multiplying by the derivative of the inside. So chain ruling the outside, multiply by the derivative of the inside, and then I can plug stuff in. So I have negative 4 f, and I'm doing this at 4. So f of 4 is 3, and f prime of 4 is negative 1. So I have negative 4 times 1 over 3 squared times negative 1. So that will be a positive 4/9. Okay, so for the last one with this, and I think this is supposed to be D, it changed, you're going to do an exponential rule. So just like any other time, when you have this 4 in front, you bring it down, and then the derivative of e to the x is e to the x. And so this would just be 4 times e squared because we're plugging in 2. Now, if I change that a little bit and I said that this original function was 4e to the f of x, then we would be using our chart, which probably would have been a better problem to use. So let's say that the problem had been 4e to the f of x that we were taking the derivative of at 2. You would still bring down the 4. You would repeat and then multiply by the derivative of the exponent. And then since these are at 2, that's what we're going to be plugging in. So 4e to the f of 2, and you look up f of 2, and that's 2. And you look up f prime of 2, and that's 7. And so in this case, you would get 4 times 7, so 28 e squared. And that would be a decimal that you could get, or it's probably best just to leave it like that, and we can all see what you did. Okay, for example 3, we're going to look at these two graphs. I have f and g, and they're not the straightest in the world, but we meant this to be a perfect diagonal. This should be flat, and this is diagonaling downward with a slope of negative 1. When you do the graphs, you're not given all that information as you were before. So let's think about example A, f times g prime of negative 1. That is a product rule, so you'll be doing the first times the derivative of the second plus the second times the derivative of the first. Now when you go to find these values and you're looking at these graphs, the f and the g values are easy. So f of negative 1 is negative 1. And g of 1, which is supposed to be a negative 1, excuse me, g of negative 1 is 1. It's just the y values. So we have the two y values, we can just look at the graph. Now the derivatives at those, you have to think of the slope of the tangent line, or in this case the slope of the line, because they are that special case where they're the same thing. So this slope is up 1 over 1, so the whole line is a slope of 1. On the g graph, the flat part is a slope of 0, and this downhill part is down 1 over 1, so it's a slope of negative 1. So everything there has a slope of negative 1. So if I want g prime of negative 1, I'm wanting the derivative or the slope at negative 1, which would be 0. If I want f prime of negative 1, I want the slope at negative 1, which is 1. So that's how I get the numbers to fill that in with. And obviously this is 0 and this is 1, so my answer is 1. Okay, for part B, we have f plus g prime of 0, and as we've discussed before, that just means f prime of 0 plus g prime of 0. So in this case, I'm just looking at the slopes. Well, if I look at the slope for f at 0, it's 1. The slope for g at 0 is not defined because that is a sharp corner, and we don't have one single slope that works there. So I basically have 1 plus undefined. If you get that situation, you are undefined. That concludes this lesson.